So it's my pleasure to introduce the first talk today. It's by Dr Althea Wilkinson, who will come up in a minute. She did a degree in physics here in Cambridge, and then she went and did a PhD in radio astronomy at Jodrell Bank, part of Manchester University, one of the heroic places for me when I was growing up. So she switched then to go to California, working with optical telescopes, returned to the UK, back to Manchester University, and did more numerical work on galaxy simulations. Brought up 2 children in the middle of it, and then has been running stuff for the European Space Agency, a mission called Planck, which you may have heard of, and most recently involved with the Square Kilometre Array Signal and Data Transport Consortium. So she has a lot of knowledge of what's out there and of cosmology. So it's great that you're going to come and talk to us today about, as you see, insights from modern cosmology at the beginnings of the universe. So thank you, Althea.
Okay, well, I should make it quite clear at the beginning of this talk that I'm not a theoretical cosmologist, so this is not going to be a very theoretical talk, but hopefully will be all the more accessible for that. Right. So where I'm going today, I'm going to look very, very briefly, because as you've heard, Ernest is going to talk later this afternoon in much more detail about the biblical origins, Genesis 1 to 3, etc. So I shall just very briefly skim through the biblical background to the ideas of the cosmology of the ancient times. Then I'm going to look at the scientific story. I'm going to look after that, how far back can we go, and ask the question of what can we say about where it all came from. And then finally, to tie up just a little bit of a thought about relating God's work and his word. So we've heard quite a lot about God's word yesterday. Today perhaps there's a little bit of the redressing of the balance, looking at his works. The basic question which we often confront when we talk to people who are not Christians, or even some who are Christians, and I'm particularly aware of this because I spend a couple of weeks a year talking to students in Kenya about radio astronomy, but I find a lot of them have real trouble because they are devout Christians and they find there's a conflict. They tend to be evangelical or charismatic Christians, and they find they have a real conflict between accepting what we're telling them about science and what it says in the Bible. So I take quite seriously this question of if we take the scriptures seriously, does it mean we have to rule out some of the things that science is saying, and vice versa? And I'd like to ask if it's even valid to ask whether science offers explanations for things that compete with scripture. And I hope you'll find by the end of the talk, I think the answer to that is no. We tend to have expectations. I mean, we all tend to have a tendency to expect scripture to fit in somehow with our worldviews. And our modern worldview is very much shaped by the way science has developed. So we tend to expect scripture perhaps to have hints of revelations of things which we're discovering. And I would suggest that really isn't appropriate to be looking for things like that. It was, of course, phrased for people in the ancient Near East and was written in terms of what they could understand. So I'm a great fan of trying to read scripture in context, who it was written for, the style it's written in, etc. And equally, we shouldn't be tempted to, having made a discovery in modern science, we shouldn't be tempted to try and read that back into the scriptures to say, oh, we've discovered a Big Bang. Oh, perhaps that corresponds to the creation of the world. You know, I think we need to be careful about thinking really hard about making those equivalences. Now, to look very briefly at the origins in the Bible, we of course know the first place you come to is Genesis 1. In the beginning, God created. And almost immediately after that, God said, and I find it fascinating, this link between creation and speech, or transfer of information. The quantity of information in our universe is quite stunning. and this idea that God is transferring this information, I find is a very helpful idea. It's picked up again, of course, in the New Testament, in John. In the beginning was the Word. Jesus is made to be the Word, the source of all the information in creation. I could go to numerous other places, as we heard yesterday. We could look in the Psalms, we could look in Job. Job's a beautiful place to look for descriptions of creation. Lots and lots of places. But I'm not going to go into that any more deeply. I shall leave that for this afternoon. But what I think we have here, overall, is a poetic, symbolic, metaphorical, if you like, description of the creation of a place, the creation of its inhabitants, human and otherwise, and the intimate presence of God, the joyful presence of God, and that the relationship between all these is very joyful and very good, as we know. Now, what sort of cosmology does that picture give us? And if we look at this picture, it more or less is taken as a description from what's in the Bible. We have the Earth, and notice that they didn't know the full extent, even of their local bit of the Earth. So it doesn't have, well, it has edges, but it has edges that are confined by the firmament, which is what you take for granted if you look outside. There's the Earth and the bowl of the sky. Logical. They put the sun and the moon and the stars inside the firmament, interestingly. And we know that there must be floodgates in the firmament, because if you're going to confine your waters above the firmament, we know it occasionally rains on us, so there must be floodgates. And they go all round. Presumably this is the ocean of chaos. We have here the abyss, Sheol, and the columns of the earth. They didn't really understand what was underneath them, which we'll hear more about in the next talk, and they certainly didn't really understand what there was above them. But what this does tell us is that God has created and is viewed as sustaining everything. And by everything, I would include all natural processes and all the laws. Creation does have a beginning, possibly created ex nihilo. After Janet's talk yesterday, I am very tentative about even suggesting that. That the sun is the creator, sustainer and ruler in a supported and parallel activity, perhaps with God as the inspirer, the sun as the activator of creation. And, God, of course, being present in all time, knew that this wasn't the end. He knew that there was a lot to come, the fall, everything that leads up to us and beyond, however far we happen to extend, which we don't really know about yet. And what has God shown us? Well, we have revelation in two parts, I think. We have revelation in God's word, of course, but also in the works. And this is very much a talk about what the works are revealing to us. We have the observable universe and the contents, as mentioned by Paul. We have no excuse for not knowing about it. And we've heard lots of quotations from Kepler so far. This is one of my favourites, that to pursue investigating the universe, in other words, to do science, is just thinking God's thoughts after him. We may be slow, we may do it haltingly because our intellect is impaired, but hopefully he is leading us through it. So what do God's works show us about the beginning? Well, when we stick our heads through the firmament, what do we see? We probably don't see the wheels of Ezekiel, but we certainly see wonderful things. And I hope all of you who are very familiar with astronomical pictures will bear with me while I attempt to set the scene in terms of scale for those who aren't familiar with looking at astronomy pictures every day, and also to give an idea of the mutability, the changes that are happening in our universe all the time. It used to be thought that the universe was a very static place. Actually, what our current research is showing us is that it's busy out there. But to get a bit of perspective, I wanted to start with this picture. I don't know how many people have seen it before. This is a picture of us there, taken from within the solar system. In fact, just 3 planets further out, from under the rings of Saturn. This is just it's our local backyard, the solar system. On the scale of the universe, it's really, really tiny. And in which case, we are even really, really tinier. This is where we put all our 7 billion, coming up 9 billion people. And I'm not going to launch into an environmental talk at this point, but I easily could do. I think it behoves us when we're sitting here thinking about, well, A, thinking about the farthest reaches of the universe, but B, thinking and discussing about what God could have meant by this, that, and the other. We're really a very tiny part of it all. But I want to move on out from there. That was our solar system. I now want to move on out to what's the equivalent of our celestial city, our galaxy. Anybody who comes from the southern hemisphere will recognize this as the Milky Way. We can't see it as well up here, sadly. But this is our galaxy. This is our flattened system of stars in which we live. And this picture, you can tell various things from it. First, we're not at the center. The excitement is going on in here, clearly. So we are quite a way off the center. Another measure of the dethroning of the status of humanity. The Hebrew picture of the universe was very anthropocentric. As we go through, we get less and less anthropocentric. It also has, as well as lots of stars, it has a lot of gas and dust. And in that gas and dust, there are a lot of organic molecules which are the basis of DNA, RNA. In other words, could be the building blocks of life. That is just one little part of the clouds in the Eagle Nebula. It was known when it was first seen as the hand of God, for obvious reasons. But what I'm showing you this for is because I believe it's evidence of continuous creation. I was fascinated hearing Janet's talk yesterday about the idea of creation being a once for all or creation being a continuous process. To me, I've never thought of it as anything other than continuous. There are stars being formed there. You can tell because they're lighting up that gas cloud. There's probably another one there, probably there and there and there. Wherever you look throughout the universe, there are new things being formed all the time. Now I've flown up above, well, in the imagination, flown up above that disk of the Milky Way and are looking down, face on, at a galaxy which is like our galaxy. It isn't, of course, ours because nobody has ever done this journey. But isn't that gorgeous? What a wonderful place we live in. You can see those dust lanes now out along the spiral arms, and you can see the center. But you can also see lots and lots of blue stars here. We understand the life cycle of stars really quite well, just using physics and physical processes and the laws of physics. And we know that these blue ones are much younger than these ones in the center, these sort of more yellowy ones in the center. So here again, evidence of the continuousness of creation. And now moving a little bit further back, galaxies like that, which actually incidentally contain 100,000 million stars, and at 10 planets per star, that's an awful lot of planets there. I want to move back even further away now. Galaxies used to be thought of as these very beautiful static things, but of course they're not static, they interact. Here is a picture of this galaxy has flown past this galaxy, becoming warped in the process and ripping off material, which is now winding round its middle. Eventually, probably, they will, because they're probably gravitationally bound, they will actually merge into one galaxy. This is a long timescale process, as you might imagine. So this is change happening over a long, many, many millions of years. But we're also sensitive now, thanks to improvements in our instruments. We're sensitive to change that happens very quickly. It turns out that probably when things like these galaxy mergers happen, some sort of violent event is triggered. A few years ago, we detected, or radio astronomers, radio telescopes detected, a sudden flash, a sort of random flash, like a pulsar, but not systematic, just one, from space. We didn't know where that one actually came from. But then another one did the same thing and did it twice. And that meant we were able to localize it. And it did in fact come from a distant galaxy. Yet again, evidence of something changing, happening. And now we've detected many of these. Now there's a new telescope in Canada which detects many a week. So again, change in the universe. And even more wonderfully, we're not restricted to the electromagnetic spectrum anymore. This is a simulation of an event which was detected by a gravitational wave detector a few years ago. It's the merging of two black holes, one 29 times the mass of the Sun, the other 36 times the mass of the Sun. Quite extraordinary event. They merged within 20 milliseconds. They became bound and merged just like that. And they became one bigger black hole. Is that creation happening of the bigger black hole? Is it evolution? Is it God maintaining processes which lead to that? I don't know. Perhaps this is something we can discuss afterwards. But it certainly seems like yet another evidence of change in the universe. Now, backing off even further, galaxies like to live in clusters of galaxies. And when they've done all this merging, that tends to be what they end up as. They lose the structure but just become a big heap of stars. This is a very rich cluster, Abell 2218, and that means that there's a lot of mass contained here because there is dark mass that we can't see. We know that because we can see another wonderful thing here. All these little arcs are in fact images of galaxies from way behind this cluster, which have been imaged by the gravitational field of that cluster and are forming parts of Einstein rings around there. And it's actually a very useful way of being able to see very distant galaxies. This one particularly was a spiral galaxy from its nice blue colour. And of course, we go further and further. As we go further and further out, we see structure. We see clusters, superclusters, filaments and nets of structure all the way out as far as we've so far been able to see. And we can't see the edge of the universe, of our universe, because of the finite speed of light. But as far as we can see, we know there is this structure, and we know there is this change going on. Now, I want to talk now about going back to the origins. This has given you hopefully a context. I want now to go back to the origins, and I want to make the remark that there are two sorts of science. There's the observational, the practical, the sort you can repeat and get the same, hopefully the same answers, or statistically the same answers. And then there is the theoretical, mathematical sort of science, which when combined with the experimental observations is the very powerful way that science proceeds and makes advances. But due to the power of mathematics, such work can make predictions and can build models and can move into regimes where no observational proof is possible. And this has actually been referred to a few times earlier on, and we'll come back to that in a slide or two later on. But to what we can measure, how do we actually get an idea of what's going on in this universe? Well, a very important tool is the redshift. By looking at the light from the galaxies, looking at the absorption lines in that light, the top here is supposed to be the absorption lines seen in a laboratory, and the bottom here is a spectrum, red shifted, so shifted to the red because it's moving away from us. So that simply is the way it's done. It all started earlier last century, about 1920s and 30s, when Hubble and Hummerson started measuring, looking at lots and lots of close-by galaxies and measuring these redshifts. Another person called Slipher had already looked at measuring the distances in a different way using a variable type of star. So he already knew the distances of all these galaxies. And when that data was put together with the velocities measured by Hubble and Hummerson, actually I think mostly by Hummerson, his student, this is the result. You find that the further away an object is, the faster it's retreating from you. What a strange effect. What on earth did it mean? Well, many people thought about it and came to the conclusion that this would be the same regardless of which of these galaxies you happen to be living in, that it was due to the expansion of space carrying the galaxies with it, rather than us being the centre of the galaxy and everything moving away from us, or us being the centre of the universe and everything moving away from us. That poses all sorts of interesting questions if you consider the expansion continuing in either direction. We won't take it forward in time today. I want to look at running the expansion backwards. If you run it backwards, this is what naively you get. So if you imagine it just linearly collapsing backwards, the logical conclusion is that at some point all this stuff, this structure we've been looking at in the universe, has to go back into a single point, or what's called a singularity, a mathematical singularity. It, in the process, would become incredibly hot and incredibly dense. But actually there are problems, which we don't need to discuss today, but there are problems with that very simple picture. And it needed another idea to make that picture become more feasible. And that idea was the concept of inflation. Now, for those of you who are not used to looking at graphs, please note that these scales are logarithmic. So we're talking about incredibly tiny times and incredibly tiny distances. So these are centimetres up here. Here's 1 centimetre. Here's 10 to the minus 60 centimetres. I hope everybody is happy with that notation. If anybody isn't happy with that notation, it just means it's very, 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 very tiny. And we're talking about times of 10 to the minus 45 seconds here and 10 to the 15 here. So what we think, the picture of inflation, what happens is we pick up from the time when physics begins to work. There's a point beyond which physics won't take us further back, called the Planck time and the Planck length. We pick up at this point, and for some reason that we don't understand, something has gone on here which has caused the universe to start expanding. So the whole framework of space-time is expanding and accelerating away hugely. So within 10 to the minus, between 10 to the minus 32 and 10 to the minus 35 seconds, very, very short time, the universe has gone from being the tiniest thing we know about to a centimetre in size. That doesn't sound like much, but it's huge expansion. And then at this point, equally, something we don't know anything about, we don't understand, happened, and it stopped expanding. And just went on in a normal sort of linear fashion, the sort of expansion we see now. So two bits we really don't understand there. But that leads us to this picture of the history of the universe. And this is the standard picture of the history of the universe from the point of view of science that I am giving you now. So this is I'll do this in 2 sections. This is the first bit, the very small bit, the bit very close to the Big Bang. Here we have the Big Bang, whatever it was, and the inflation phase here. And then immediately after inflation started the phase of, it's still very, very hot, very, very dense, but it's expanding and cooling. And as it cools, we're in the sort of dense energy field where matter and energy are interchangeable, and particles can pop in and out of the energy field. And we begin to see the creation of these fundamental particles which build up our picture of the particle universe today. So quarks and tauons and neutrinos and all these particles are formed here. And this is the energy to which all these accelerators are trying to reach back. They're just trying to investigate what's gone on here. Here we have, things are getting cooler. We have a plasma which is made up of charged particles, so electrons and positrons. But at this point here, the electrons, it gets cool enough for the electrons and the positrons to get together to form hydrogen. And this allows the radiation, which has been formerly making a sort of fog with the particles, allows it to escape and come towards us. And that's the point at which I switch to the next picture, which I'm sure many of you have seen before. So everything that happened in the previous picture happened in this light area here. We now come to this point of recombination here, where the hydrogen has formed and the radiation is released. And this happens about 380,000 years after the Big Bang, which sounds like a long time, but you can see from the extent of time in this direction is actually a blink of an eye after the Big Bang. And this radiation, which escapes at this point, has imprinted on it the mark of quantum fluctuations, which happened right back here when the universe was of a size where quantum fluctuations mattered. But they're expanded by inflation to a much bigger and detectable size. And it carries this information with it as the photons come to us through all the subsequent structure which forms in the universe, which I talked about earlier, to be detected by a satellite such as Planck or WMAP here. And this is where my part of the story comes in. I was very privileged to be able to be project manager for the European the UK low frequency instrument we built at Jodrell Bank. This was a ESA mission which went up, well, you'll see when it went up in a minute. It was international in scope, and we built two of the low frequency channels. We built the amplifiers for them. This is what we actually built. We built 5 of these little gold boxes, which are low temperature, very low noise cryogenic amplifiers. And this picture is, we'd been testing it on a vibration bed because we wanted to make sure it would survive the stresses of launch. Fortunately it did. We were looking there to check that the screws hadn't come out. This is where the boxes went eventually. They went behind, the amplifiers went behind the horns, which actually received the signal from the cosmic microwave background. That's what this radiation is called. And other elements went in there. Then it was all put together for the spacecraft. There are the horn, the little horns we were just looking at there. This is the part that was cooled to 20 degrees above absolute zero. And this is the rest of the piping, plumbing, leading to the support module here with all the electronics and the power, etc. That picture I like to show people because sometimes people seem to have the idea that it's very easy to send things into space and have them work. This took about 9 years to build and test and convince ourselves that it would work. And it took many hundreds of people to do it. It was the best humankind could do at the time. Eventually we got it on the front of the rocket, the Ariane 5, and it was launched from French Guiana in 2009. It went up, made its surveys of this sky, and eventually in 2018 we were able to release this final map. Why so long? Well, again, it took another army of hundreds of people doing their utmost to remove all the foreground radiation, because there are lots of other things in front of you. There is our galaxy, there's other galaxies, there's all these things which have to be subtracted accurately. What does this tell us, you might ask? Okay, lots of dots. Well, I know there's one person in the audience specifically who's asked me to say what we do with this data. What we do with it is we do a spherical harmonic analysis on it. You don't need to know what that is in detail. But what it does is it picks out which of these structures is most important and occurs most often. And it's the thing you can see by eye. It's something that's about 1 degree across. And it turns out that this position of this peak in the power spectrum, so we do the analysis and get a power spectrum, this power spectrum is incredibly sensitive to the conditions in the early universe. And by comparing these observations with our models of the early universe, we can tell all sorts of things quite accurately about the early universe. This is just the highlights. The highlights are probably that this picture of inflation is almost certainly correct. That the universe as we know it started 13.813 plus or minus 0.026 giga-years ago, giga-year being 10 to the 9 years. So if we want to equate the Big Bang and creation, then we have a date for creation. It's an interesting thought. Quite well known. We may not know what it was, but we certainly know when it was. And the other thing, which is extremely humbling, is that we actually know very little of what's in the universe. The things that we do understand very well, atoms and things like this, and you and me, occupy about 4% of the universe. About 23% is occupied by this stuff called dark matter, which makes the galaxies move and the stars move in the way they do. And the rest is this stuff called dark energy, which we don't understand at all. Nobody understands it at all at the moment. So if that's not humbling, I don't know what is. God has got a lot of surprises in store for us. Can we look any further back? I told you that this was from 380,000 years after the Big Bang. Can we get further back? Well, maybe we can if we ever get to the stage where we can detect gravitational waves from the Big Bang. Not like the gravitational waves from the black holes I was talking about, but gravitational waves from the Big Bang, the event itself. So the cosmic microwave background came from 380,000 years after the Big Bang. If we can get back to looking at gravitational waves, they go right back to 10 to the minus 43 seconds after the Big Bang. That would be very interesting, but of course the next question we ask, what was before? Could there even be a before? We had some discussion of this yesterday. If space and time are co-created, does before have any meaning? And in which case, can we ask where did everything come from? If it came from nothing, if it came from ex nihilo, can we ask that question? Our current, well, we can ask and we can certainly try and answer. Our current understanding of physics, as I've said, only takes us to this 10 to the minus 43 seconds after the Big Bang. Before, we have to be supported by mathematical hypotheses. And this is the point at which we're getting into that other sort of science that I mentioned. Where does that take us? We do know our universe is finely tuned for life, or do we know that we're finely tuned for our universe? Discuss. But let's look at some of the possibilities which people have suggested. And I should add that all of these are actually unobservable. One idea, and I really picked up on this idea yesterday when I think it was Peter, first thing in the morning, was talking about mathematics from the Platonic or from Descartes' point of view. And there are people who seriously are talking about the ultimate reality is mathematics. So, who knows? But these ideas come round. Multi-worlds. This is the idea which comes from the quantum mechanical idea that put forward by a grad student in quantum mechanics, that every time a system makes a quantum mechanical decision, or we make a decision, or any decision is made, the universe splits, and the two decisions, the two paths, go on in a different universe, which would mean that by now there must be billions and billions and billions of them. So, although a fascinating idea, perhaps not very helpful. Seriously, people talk about, are we in the Matrix? Are we in a giant computer simulation? How would we know? And if you were able to make universe simulations, wouldn't you make lots of them? And perhaps the computer programmer's called God, or, you know, I don't know. But that is a serious suggestion. Another serious suggestion is that there should be a single theory of everything, a TOE, as they call them, that there's one universe and that this is it. And this involves the unification of all forces, which we've not been able to do yet. It would also involve explaining all the very particular values of the physical constants, etc., etc. This is a hugely difficult task, and we're nowhere near achieving it. So that one's on hold. Eternal inflation. The idea here is that, okay, our universe started out, went through its inflation phase and went off in its own little bubble, which I've said we can't see the extent of. But maybe there are other little universes starting off and going randomly off in their own little bubbles. And maybe there are millions and millions of these, and this is just going on forever. And this is one version of what's known as the multiverse. The issue here, of course, is that because it's all outside our universe, which we can't see to the edge of, we are never going to be able to see any of this. The theory which has been occupying physics theorists for about the last 40-odd years is string or M theory, which seemed initially to be very elegant, that particles are actually not really particles. They are little loops of string, and they look like different things because you're seeing different modes of vibration. So all those fundamental particles I was talking about would in this sense be interpreted as these strings. It's simplified into a slightly less complicated, well, not less complicated, a summarizing theory called M theory. The problems with this is that it requires 11 dimensions. It requires at least 10 to the 500, if not 10 to the 1,000 universes. That is a terribly big number of universes. There are only 10 to the 80 particles in our observable universe. It's a crazy number. If we have to make that crazy number of universes to explain one which has the right conditions for us to exist in, is it more rational to look at that, or is it more rational to look at a supernatural being that has created this one for us? Again, discuss. And some people don't like the idea of internal inflation, so they've suggested that the universe maybe goes through a cycle of Big Bang expansion and somehow collapse, Big Bang expansion and somehow recollapse. That's quite popular at the moment, but who knows? As we say, getting speculative here. And the trouble with all of these pictures, they're wonderfully fun to think about, but the problem with them all is plausibility and falsifiability. To my mind, what they do is they all push the question back just one step further, you know. Okay, what was before the universe? Okay, what was before the multiverse? We really aren't any further forward. So lots of fun to think about. I'm not so sure they're going to actually answer any questions for us. So finally, back to how the Word and what God actually did compare. And by this I'm taking science as revealing what God actually did. Yes, there was a beginning, a spectacular beginning, though whether we have to identify that with the creation moment, I'm not clear. The subsequent development of creation seems to have been essentially self-mediated. It's comprehensible in terms of physics and the laws and the processes which we believe are the way God has chosen to maintain what's going on in the universe. They didn't require supernatural invention, the bing, there's a star, or bing, there's a frog. It didn't need that. That's all encompassed in what God has provided, the machinery that God has provided. It took a very long time, and I'm sure Hugh's going to refer to that in a next talk, and no one knows how it all started. But I've been wondering in the last couple of days, a question that's come to my mind, the extent to which the natural world has been subjected to the fall. It seems totally unreasonable, irrational, to suggest that all these planets and stars and galaxies should have been subjected to a fall because of our failings, when they've never been anywhere near us, never had any contact with us at all. So I find that difficult to deal with. I also find it difficult to deal with the fact that mankind only came in right at the end of this creation process, and that the Earth has been around for a very long time, as Hugh will be telling us, and that the processes, the natural process of the Earth, the volcanoes, plate tectonics, earthquakes, etc., have all been a necessary part of the machinery to make the Earth suitable for us. And I would really welcome a discussion on that and input from theologians and people who have more knowledge of it than I do. But what we can say is that the universe seems to operate according to these laws and processes which we assume to be ordered, rational, and God-given. We can understand these laws. One of the remarkable things is that we can understand them, and that there does appear to be rationality, that our minds presumably are in the image of God, in the image of the Maker. And that's the remnants of whatever has come through the fall makes us capable of understanding these laws and of being improved, being perfected by studying the natural world, studying what God has actually done. It suggests we're being led to understand what God has actually done. And I was fascinated again by Peter's comment that this was one of the justifications of science, was that it was enabling us, as seen in the 17th century, as enabling us to recover partially from the fall. So word or works, why not both? God is active in natural causes and effect as well as in the supernatural. And it seems that creation has been endowed with these processes and laws which enables it to mediate its own development. And presumably it's God's freeing love which has enabled this to happen. And the universe is growing in what's intended to be because it's been given this freedom. And these scientific processes seem to me to be the normal way that God chooses to work in creation. We're revealing what God does. And it all seems to be consistent with this, by which I mean not that he just touches the blue touch paper, but that also he is present in the sustaining of everything throughout the process. Science enables us to explore what God has done, but we are very far from understanding it all, as I hope I've illustrated. And our hope is, of course, to know eventually, even as we are known. We're right at the beginning. Let's stay humble. Thank you.
Thank you for your excellent timekeeping. Since you talked about time throughout, that's very good. But it means we've got a full half hour now to have a good discussion of things that it's raised, and people are thinking about it immediately. So, Julie's got the microphone.
Yeah. Okay. Thank you. Thank you for the great talk. I I'm troubled, I think you are, with this idea of the awful investment in space and planets and the whole universe. Why is it so massively big just to put us on this little tiny planet?
Indeed, yes. I mean, there are arguments that it has to be that big to develop the conditions for us, but I find that difficult to believe as we find more and more stars with planetary systems, and we've only looked at the closest ones. You know, there doesn't seem to be anything that terribly special about our planet, apart from the fact that it seems to be terribly special because we're here. And, you know, the conditions are, the number of coincidences which make it possible for us to be here are legion. It is, from one point of view, it looks very fine-tuned, but on the other hand, it looks as if there are possibilities for life, if perhaps not intelligent life, in many, many other places. And if God loves life, why would he not love it in abundance? So.
We'll go to the back.
Yeah, just actually two parts to the question. First, string theory. I always find that a bit funny as an explanation of matter because what are strings made of? That's the first thing. The second thing is that it seems to me that this whole acceptance of the creation of the universe as a black bang, of course there wouldn't be a bang back then because we wouldn't have our cell, but nevertheless the idea of Big Bang depends upon the steady state expansion of the universe. We're talking about a bouncing possibility, but so it goes back to the beginning again. But what about a periodic expansion period of so many billion years in which it actually expands with more black holes occur relative to star expansion, something like that. There's a season that occurs where actually it recedes for a while, because there are actually theories such, well not theories, observation like magnetism, the poles of the universe change, magnetic poles every so many 100,000 years. So just to add that to your thoughts. Thank you.
Well, let's start with the Big Bang. The Big Bang was a name coined by Fred Hoyle rather scornfully because he and other scientists at the time did not like the idea of a beginning in the universe. We saw that mentioned yesterday, that people were frightened of the idea of a beginning of the universe because it looked as if it tied in too much with scripture. And so his this stupid theory of a Big Bang. So you shouldn't read any more into the name Big Bang than it's a joke. So, so that, you know, of course there wouldn't be a, well, who knows what there was, you know, when you start expanding space and time and accelerating it, who knows what happens. Now, gosh, you're going to have to give me that question again in bits because I'm not going to remember all.
I can answer it if you like.
You, please answer it.
It's about the magnetic poles of the Earth switching every few million years, which they do. And it's simply because the centre of the Earth is made of nickel iron. It's very hot and it's convecting vigorously, and it creates its own magnetic field. And every now and then it goes unstable, and the north and south poles flip. It's reproducible, and it's a self-sustaining dynamo.
There's a really interesting corollary to that that I saw just recently. I believe the pole is moving quite fast at the moment.
Yes, if you have an Ordnance Survey map and you're using a compass to navigate, you should look at the bottom of the map because it tells you the magnetic declination. So the magnetic North Pole is different from the geographic North Pole, and it moves. Yeah.
Is it true that it's moving quite fast at the moment because of the melting of ice around the polar regions, which is altering the shifting the balance?
No, I don't think so. No,
Not true.
No.
Okay.
It goes round in ellipse, but it's true the Earth wobbles a little bit, and a big earthquake, like the Japanese earthquake, actually measurably changes the rotation axis of the Earth by a few microradians.
Right. Okay.
So, another question on that. I shouldn't be talking about here. Another question here.
Thanks again for a really inspiring talk. It's the second time I've heard you talk now. I'm just considering the images that you were using, and sometimes the images appear to have taken from, like the one for our Milky Way galaxy, for example, from outside of the galaxy. So I was wondering, has NASA got the technology then to send their cameras outside, and how were these images put together?
No, that was an image of another galaxy. That was not our galaxy. The looking at the Milky Way, that was obviously taken from Earth. But the one where I said, we're imagining flying above the galaxy, no, that was a different galaxy, which we have reason to believe looks like ours. Various mappings of where stars and gas and etc. lie lead us to that. But no, we haven't got the technology to go outside our galaxy yet. The distances are huge.
Well, we have sent a spacecraft outside the solar system.
We have sent one outside the solar system, but of course that's just very tiny compared with...
It took a long time to get there. Another question, yeah. Right at the front, Julie.
I'd like to ask a very ignorant question, and then a rather perhaps facetious one. So firstly, you had a pie graph saying that we represent the 4%, which are atoms, 23% dark matter, 73% mystifying dark energy. What is the matter in the matter if it's not matter as in atoms? And then what is the sort of frame of of not understanding in which this dark energy lives? Because if you say energy, I think about energy, but you seem not to be meaning that. And the facetious question is, so what if the creation of the universe actually represents, as it were, a fall or a separation from some different state, which is all that we can conceive?
Right, okay, the pie chart first. If I knew the answer to what dark matter was, I would be doing very well, and I would be putting up for a Nobel Prize. No, people don't know. There are various suggestions. It might be axions, might be some other weird particle that we don't know what it is.
Why is it referred to as different from dark energy if both things are unidentifiable categories?
Because we know much more about dark matter. We know where it's localized. We can see its action, even though we can't see it.
Einstein lensing?
By the way stars move, by the way galaxies move, you can tell that there's a lot of stuff there which we're not seeing. And it's acting just like ordinary matter, it's gravitating. So, we just haven't quite identified what it is yet. If I knew what dark energy was, I'd be doing even better. Dark energy is, it's essentially something that is acting against gravity in the universe to actually, the universe appears to be starting to accelerate again. And it's something so it's working against gravity, which of course only works one way, and it's going the other way, and it's at the moment winning. It seems to be a property of a force field in the universe. We don't know what it is, but I don't know if that helps much. So the other question was?
Does the universe represent a separation of state, a fall of state from something different? Because we imagine a point coming out of nothing, and yet...
So could it have come through from something else, you mean? Well, I think that's really the idea of these bouncing universes, is that you go through one of these singularities every so often and emerge. So, it's certainly a model that's being considered.
Good. Halfway back. Yeah, just sorry, halfway back. Yeah.
Hi. You didn't talk about how you talked about how we go back to fight the Big Bang from the recessional velocities, but you didn't talk about how it goes forward and also when you were talking about the clusters of galaxies, one of the things that I've been studying is the fact that as galaxies form in these clusters and then on into superclusters, they die. They're red and dead galaxies. And the question that I have is, how does the science of this cosmology impact your thoughts on the promises we're given in scriptures like Revelation of eternity in a universe where we can see these structures forming that actually cause the death of these galaxies, the stripping of these resources?
Yeah, really good question, one to which I don't know the answer. Yeah, I think going forward, there are various ways we can look at what's going to happen, of course. And, you know, we have the big crunch, we have the big rip, we have all sorts of fates for the universe. All of them seem to be fairly violent. None of them seem to tie in terribly well with the promises of the new creation. It's a question I would love to address to any theologian here, where they think the new creation is, because, or will be, I should say. Because it seems to me that what we see in the universe is always changing and evolving and dying and being recreated, and you know, if you put the new creation on Earth, then you have the problem that eventually the sun's going to go red giant and you'll be swallowed up. So, you know, all this picture doesn't tie in. So it's making me think more and more that perhaps we are misunderstanding the way to confront these two sets of pictures. You know, that we shouldn't be looking in the science story for what we see in the Bible, and vice versa. But if anybody has any better solution to that, I would be delighted to hear it.
Well, I think, perhaps I'll just say since I'm here, the new creation is Christ coming back, isn't it, into this universe. And the first time God became incarnate was when Christ first appeared. And now that's a supernatural cosmic event, that God becoming incarnate.
Yeah.
And that's what he says he's going to do at the end of time, that God will be incarnate. And he's going to make all things, he's not going to make all new things, he says. He's going to make all things new. He's going to renew everything. And by everything I take it to mean the whole universe. And it clearly will have different sort of physics from now.
Yes.
So I don't think we should be thinking of the normal processes of this
Yes, I think that's right.
continuing on. I think it's some cosmic event where Christ returns, where God returns as Christ, and makes things the way he meant it to be, without, the Bible says, without the sinfulness that we've brought into the world. So I think it's a mistake to wonder about physics, but I mean, I do think it'll be great. It'll be a place where we're at home, and there'll be many mansions, and they'll be just right for us, and there'll be shady riversides and cities, interestingly, which are human creations. You know, so some of the best things of human creativity carry through into the new creation. It says the honour and glory of the kings will be there. So it's something to look forward to as being the right place. But I think to speculate beyond that and to try and put physics into it, I think is silly.
Yeah,
I think,
it doesn't work.
But I think physicists will probably have things to do there. So I think I'm a volcanologist. I think there'll be great volcanic eruptions, which will be spectacular, but they won't hurt anybody. Sorry, another question from you.
Thank you for your talk, and personally get caught by your question about the nature subject to fall, the question about whether nature is subject to fall. And personally, I deeply respect your methodology, your talk, but I'm not that methodology, but I try my best to reconcile two things: the fall of human being and then the reality of nature. And actually, you talk about the creation. You talk about the Genesis chapter 1, the verse 1, but actually, verse 2 gives some insight, I guess. because verse 2 said the earth was formless void and darkness covered the face of deep, while wind from God or Spirit of God swept over the face of the waters. And this description said that the universe was a void before God creation. I don't know what the exact time moment about is talking about. If Big Bang Theory is compatible with the truth, I don't know what exact time, but here he exactly talking about some void, some formless, some darkness. And as you mentioned, you talk about the energy in the universe. About 4% is something we can clearly identify as atoms, and all the things that God created that He quite good are made of atoms. If we merge these two languages, and actually that means 96% are not atoms and a void without the grace of God. And if we see in this way, the fall of human being is the fall is the human. It was in total reconciliation with the Creator God, and he see everything good because he focused on what he should focus. That means the graceful creation, the atoms, the trees, the plants, the earth. However, after the fall, according to the reformers, the fall of being is about not only moral but the intellectual. In the intellectual parts, they may lose the focus of the God creation. That means not lose the focus of what God sees, what is good. That means what is atom. That means what is 4%, and they look into the void, look into darkness, look into the dark matters, dark energy. They try to figure out and try to chase with the darkness. And this is, in the biblical term, what is called loss or what is called sin. And I guess the nature doesn't fall because the fall is the human being. The nature itself consists of something that is order, because in my understanding, the Hebrew concept of creation is from chaos to order, not exactly creation ex nihilo, which is come later, as the last talk we have yesterday, the 2nd century fellow, they talk about ex nihilo, but in the Hebrew world, it's from chaos to order. And if human fall, then they lose the focus from what is order to what is chaos, and they trace to the chaos, and they focus on the chaos, and they find,
Thanks.
this is what I guess I can might try.
Yeah, thank you.
Thank you. Yes, I'm not sure that was really a question, was it? So
No, it's a comment. And I think you're right that sin is rebellion against God. Instead of living in God's world in the way that He meant us to be, we've turned around and said, no, thank you, God, I want to do it my way. I want to put myself first, not your interests. So that's what the fall is, essentially. That's what sin is. Another question right beside you, Julie.
Just to say, I like yourself, I've often asked the question about why is it that there is, these enormous universes, this tiny us, and sorry, I've often asked the question why is this huge universe and this tiny us, and in fact, a couple of us were discussing this the other day, and I'm not a theologian, so I really put my head in the lion's mouth when I dare say this, because I can see every theologian going on saying, oh no, it's not. But there's a verse in scriptures in 1 Corinthians chapter 1 where it talks about how God takes the things that are foolish, the things that are small, the things that are of no account, and makes them the centre of His purposes. And in a way, the universe, I think that's what He's done with us. That picture is us, tiny, insignificant, nothing special in one sense about this lump of rock, and He makes that the place where He
I think that's lovely. Picture. Any comment from a theologian?
Ruth wants to say something. I might also say that actually the human brain is the most complex known thing in the whole universe. So it might be tiny, but there is huge complexity in humans. Ruth.
Yeah, I just want to add the thought that in quite a lot of the places of the Bible it talks about how all creation is praising God. So I thinking of the idea that the whole universe is, is it necessary? I don't know. It's not up for me to decide. But the fact that it's so huge and vast, and we can find it so beautiful, we can explore it, draws attention to how great God is.
Absolutely.
We have a theologian with his hand up, so
Yeah.
let's go to Ernest.
I think we wrongly get hung up on this question of size, and I think that's part of thinking in a scientific framework. The importance of things does not depend upon their size. The importance of things in a theological, biblical perspective is relationship. It's our relationship to God that is important. When I picked up my first son and he virtually fitted in the palm of my hand, I didn't say he doesn't matter because he's so small. So, the fact that maybe we are the only intelligent life in a vast universe is beside the point theologically. It's that God relates to us. That's what's important. And if God chose to put us in this huge universe for whatever reason, that's God's choice. And shouldn't, And also this question about, if you like, people say Copernicus made humans less significant because they weren't the centre of the universe. Ideologically, that's not true. The point in the three-decker view of the universe, three cycles, there's the underworld, there's the earth, you depicted so well in the picture. In a sense, it was demeaning, because humans were closest thing to hell, because hell was under us, and the perfection was up in the heavens. And what happened when Copernicus suggested the earth was, in a sense, in the heavens, going around the sun, was to promote the earth to a more important place. And it's looking backwards, as Peter was saying to us this evening. We project our modern thinking backwards. For many people, Copernicus liberated humanity and the earth and made them more important, because we're now in the heavens. So I think we have to be a bit careful about how we read things back into history.
Okay, we'll come forward now.
In passing, you said discuss when you talked about the fine-tuning of the universe or the fine-tuning of humans. Perhaps you'd like to discuss.
Well, obviously, I don't really know. But there are all sorts of things that have made the universe such that we can live in it. From, sort of the ratios of the masses of electron and proton, and the ratios of the different fundamental forces, fine structure. There are all sorts of things which seem to have very specific values. And if they'd varied a little bit one way or the other, the universe would have been such that it wouldn't have supported life.
So these are things that just are in physics. We have no reason why they are, but if they're ever so slightly different...
That's right. They're sort of fundamental givens, as it were, so far as we know. So it looks from that point of view, and we're sort of veering towards the anthropic principle here, that the universe was particularly finely tuned for people. The fact that we're the distance away from the sun we are, we're not too cold, not too hot, we're in the Goldilocks zone, all this sort of thing. But if these things had not been, then we wouldn't be, or we would be in a very different situation and state. So that's what I'm saying. I'm not sure whether we have, God has chosen to place us in a place where we are uniquely suited to be, and it's clear we are. We're not suited to be anywhere else in the universe. It's going to be, going to Mars is going to be terribly difficult. Or whether we evolved to fit it or it evolved to fit us.
So if you worship God, do you worship Him for the way the cosmological constants are and the stuff you've just been talking? Does it inspire awe? Does it inspire puzzlement?
I think I worship him as the the creator and founder of everything, and I don't worry too much about cosmological constants. As was indicated from the back, it's the personal relationship, isn't it?
So, Doctor, I think we have some little bit discussion about the string theory, and I think string, or the question string, what is something string? I mean, we at least we assume the world is somehow made by energy. I'm not sure if it's right or not. You can correct me. So if we assume the world is created based on the energy, and we just say the string is the basic form of the energy, and it has its own mode, and we don't need anything lower than. And I think you mentioned string theory are producing multiverse, but I guess it's only one scenario in the string theory that can
Yes.
make the.
There are many, many scenarios. I mean, that's another indication that we need a new theory. The proliferation of theories means we need a paradigm shift. We need God to reveal something else to us. It's clearly not right.
But if whatever string theory says, but if multiverse is really a case, can our Christian have the ability to accept it? That's my question.
Sorry, I didn't quite catch that. So if there is a multiverse with Christianity, I don't see why not. It's almost like saying, is the idea of life elsewhere in the universe compatible with Christianity? Well, I think God as the creator is the creator of everything. And therefore, if he's decided to create other intelligences in the universe, presumably they are also children of God. An interesting question of, whether he was, whether Jesus came to them as well. And equally, if we have other universes, then, presumably either they're not inhabited by anybody, or if they are, then God will equally have dealt with them in the way he's dealt with us.
Maybe they didn't sin.
Maybe there's a sinless universe somewhere, who knows?
Another question.
Can I be greedy enough too? So one's physics related, and I think I should know the answer to this, but I don't. You said in talking about the observing the expansion of the universe, essentially that the universe is finite. How do we know that?
I don't think I did say the universe was
Well,
finite.
you said, okay.
I said we don't actually know
I
because
think what you said was we can't see to the limits of the universe.
Yes, that's what I said. Yes.
But that implies there are some limits.
Sorry, I shouldn't have used the word limits. So we don't know if there are any limits.
Okay, so the universe can be, as far as
that's
you know,
that's another of these pictures, an infinitely repeating
in terms of the physics,
Yeah.
it could be infinite.
Yeah.
So basically, going
We
back
will
to the
never
Big
know.
Bang, it's still infinite, but it's hot and dense in some way that ultimately physics can't describe. Would be the picture.
Infinite. I think the picture is that to be hot and dense, it has to be condensed into that singularity. Quite how you identify. I mean, I'm making no statements about whether the universe is infinite or not. I mean, I don't think we know, and I don't think we ever will know, probably.
But if you follow
if it's one of these bubbles, then it isn't infinite. It's just that we can't see the edges, so it doesn't have to be infinite.
If there's one universe and it is infinite, and it follows the pattern, if you like, the picture of going back to the origin, then surely everything is getting much, much smaller with the same amount of mass.
I don't see how it could be infinite.
It's becoming more and more dense.
Certainly the idea is it becomes more and more dense, yes.
Yeah. And therefore, does it not get hotter?
Yes. Oh, much, much hotter, yes. Unbelievably hot.
So it's still infinite, but it's getting dense and hotter.
I'm not committing myself on the infinite.
No, I know. No, but I'm saying we don't. I'm asking you. We don't know whether it's infinite or not.
No.
So the possibility is there.
Well, space and time are related.
Yeah.
Is it?
Yeah.
Why?
At that stage, well, because we don't know how
No.
hot it was either,
No.
or how much time was existing. I mean, it's all interrelated. I'm not sure it gets us anywhere anyway, does it? I'm not sure any of us.
No, I'm not sure it gets us anywhere. I'm just asking the question. I'm just
I
trying to
think
have a
that's
picture
okay.
here.
It's
Of
semantics and partly.
Okay. The other question was in relation to the fall and the significance of the fall. So you you opened with an interpretation of Genesis 1 as being poetic. So is there a sense in which the cosmology is saying that, our understanding of the universe over the time scale and the emergence of life at the very end of all of that, and maybe we accept evolution as well, is there a sense in which we have to interpret the fall in Genesis as also poetic? So there's an implication that human beings were created very good and then made a choice that separated us from God. Whereas, is it possible then, or is another interpretation to say that in the ancient view, this is a poetic explanation of how we've got to where we are in terms of our relationship with God?
That's a question I'm quite interested in at the moment, and I would love a comment from theologians around the room as to what they think about that.
I mean, it's an observable fact in all of us that there's evil in the world. I don't think that's an issue, is it? And since God is not evil, then we must have done it. We could pause there, couldn't we, and have coffee? I think we will, actually. We'll start again. Thank you very much, everybody. We'll start again.